walk cycle is traveling when the walker crosses the frame of a fixed camera. It becomes in place when the walker remains centered on the screen. To compare these two types of cycles and their relationships, let's recall two basic concepts. A step is the distance between two successive foot contacts. A stride is the distance between two successive contacts of one foot. In a walk cycle, stride lengths are always equal, whether the steps are equal or not. Symmetrical cycles. A walk cycle is symmetrical when both steps are equal in length, duration, and poses. In a symmetrical traveling walk, steps follow one another. Strides overlap by half, and support durations occur at fixed points. In an in-place walk, steps and strides overlap, and support durations are distributed along the backward path of the supporting foot. This does not alter the step length, which remains the same as in the traveling cycle. However, the backward shift of the foot contacts brings the stride length down to the step length. At first glance, we might conclude that in an in-place walk, step and stride are of equal length. In reality, this is only true if the walk includes just one double support pose per step. As soon as additional double support poses are added, the support distance increases accordingly, and with it, the stride length becomes longer than the step length. Suppose the stride duration is 0. That is, the entire step duration occurs on the ground with no airborne pose. In this case, the stride in place length would equal its traveling counterpart. But a length without duration is impossible in real life. That said, in animation, anything is possible. When studying an in-place walk, beginners often make the mistake of stopping the walker at each double support phase, when these moments last longer than one pose. Doing so is misunderstanding what the backward movement of the foot during support corresponds to. If the walker remains centered in the frame, it's because they are followed by a camera at constant speed. This speed, expressed by the gap between each camera position in the traveling cycle, is reflected in the gap between two foot positions on the ground in the cycle in place, whether the support is double or not. In other words, stopping the walker at each step due to a double support is stopping the camera as well. In future episodes, we will continue our analysis with asymmetrical cycles.